Hello guys, welcome back to my channel. Today I'm gonna continue the video which I told. This is the second part of the video. Okay, so let me tell you, today I'm gonna discuss the next part of that. What was the problem? Yes, modular equation. Okay, modular equation. So if you have not watched the first part, then please go and watch the first part. You can see over there in the I button. Okay, so without wasting time, let's start. Okay, in front of you here is a code written, which is a code of what? Modular equation, which is a code of modular equation. And first let me explain you, then I will tell you how this works and what's the output constraint and how much time does it takes and so on. Okay, so let's start. So first of all, so let me dry run this sample tests once. Okay, so this is T. Wait, it is T. So 3 test cases are there, 3 sample tests are there, 1, 2 and 3. Okay, so and these are what? These are N and M. Okay, N and M corresponds to what? Like N is that is A and B, range of A and B is from 1 to N. So N is the boundary N is the boundary of A and B. Okay, A less than B. This I have told you in the first part. Now what I have to tell you, that just to recall you, let me tell you, we have got N equals to 3 here and M equals to 5 here. So from 1 to 3 we have to pick up 2 pair such that which satisfies that condition. That condition I have written over here, which satisfies this condition, that is M modulo A modulo B and M modulo B modulo A. These two should be equal, then only they are valid pairs. Okay, and the range of those valid pairs are from 1 to what? N. Sorry, 1 to N. And A is less than B. Okay, so range of those valid pairs are what? From 1 to N. This is the range. Now let me run this sample test. So 3,5. For 3,5, what are the valid pairs? Let us take 1 and 2. 1 and 2 are valid. Like 5 mod 1 is what? 5 mod 1 is 0 and mod 2 is 0, and 5 mod 2 is what? 5 mod 2 is 1 and 1 mod 1 is again 0. So 1 and 2 satisfies the condition. 1 and 2 satisfies the condition. Now for 1 and 3. So 5 mod 1. Okay, mod 3. 5 mod 1 is 0 and 0 mod 3 is 0. And the second one is 5 mod 3, which is basically equal to 2 mod 1. 2 mod 1 is 0. So this also satisfies the condition. Okay, now jump over here. So we got 2 valid pairs only. Now if we check for No, we cannot check because n is 3 only. Let's jump to the second sample test. And here also 3 it is. And if we check for 1, 2, so one thing you can observe that wherever the 1 is there, like a, if a is equals to 1, then corresponding all value of b, that is a equals to 1, corresponding all value of b in the range of 1 to n are valid pairs. This you can observe. Okay, you should have an observation of that. Like 1 and 2 are there, 1 and 3 are there. Okay, and here it will be it will also be like 1 and 2 will be valid pair, but 1 and 4 are not valid pairs. Okay, we will see how does that works. So let me change the color. So let's check for the 1 and I got some not good color. There's the one. So for 1 and 4, let's check for 1 and 4. So 1 and 4, that is 6 mod 1 mod 4. 6 mod 1 is 0 and 0 mod 4 is 0. Now if you do 1 and 4, okay, 1 and 4 are valid pair, but here the n is what? N is itself 3, so 4 it will not reach. So my observation is correct. If a equals to 1 and corresponding all value of b, it will be a valid pair. Okay, if it is in a range, like n is here 3, but 1 and 4 is valid pair, but here the range does not allow it to be a valid pair. Okay, so I hope you got. Now what I'm doing here, this is a solution code which works under n into 10 to the power 3. Okay, now n is what? N is 10 to the power 5. Sorry, n is 10 to the power 6. So n is 10 to the power 6 into 10 to the power 6 into 10 to the power 3, which is basically 10 to the power 15. And we know that it will not work in for 1 second. If it would have been given 2 seconds, then it would had worked, but it's not. Time limit has given only 1 second. So how to approach this problem in tn log n second? Okay, tn log n complexity. Let me write over here n you have to do this problem in t into n into log of n time complexity. Now how can you do? Let us see if this works. T is 10 to the power 3 into n is 10 to the power 6. No, again you cannot do. Can we do in this time complexity? And here it will be 6. So again we cannot do. So what we have to do? We have to do it in n, that is t into n. So we have to do it in linear time, that is O of n time complexity. Log n will also not work. Might work. It might work. No, it is not going to work. Let me check. The n is n for the real value. Yes, n is 10 to the power 6 itself. So yeah, and is 10 to the power 6. So one more thing you can observe here, that is, if let's say m one pair is less than m, let's say a less than m and b is greater than m, b is greater than m. Okay, so what will happen? Let's do this. That is m mod a. What will happen? M mod a is less than m, so it's okay. But since this is less than a, since m is less than b, so this will also be less than b, and we know lesser than if we do like a mod b and b is greater than a, then the modulo value will be a itself. So here we will apply that only. So its modulo value will be what? Means this total modulo value will be what? It will m mod a, and on the other hand, what we have? Okay, this is again bigger than this one. So what will be the modulo value? It is going to be m mod a. Let me write it in a correct way for you. Yeah. I am saying that let me use the black one. Yeah. So I'm saying a is less than m is less than b. Okay, so since we know a relation a mod b equals to a itself when what? B is greater than A. Okay, this relation we know. Now using this relation we will do what? We have to check first. Let's write the condition m mod A mod B and m mod B mod A. So this should for a valid pair, these two should be equal. Now using now let's say the A and B are like this, that is B is greater than A, B is greater than A and also M, and A is less than M. So in this condition what we can do is, if since we know that B is greater than M and B is greater than M, then M mod A, then B will also be greater than M mod A. We know that because it is going to be lesser than M itself. Okay, whatever it is. So finally this is going to become what? Under this that is range, what it is going to become? M mod A, using this relation. Okay, and this finally this what this is going to become? M mod A. How? Because M is greater than M is what? B is greater than M. So after doing modulo, what it will be equal? M on M itself, and then we will perform M itself. So what it becomes? M mod A. So both are equal. So under this condition, if it is so, then under this range all the pairs which are coming are valid. Okay, all the pairs are valid. I hope you understood. Now let's take some other range, like a less than b less than m. Under this condition, what we have to do, what we can do? Under this condition, we will do what? We will check for it. What we will check? Let's see what we will do. Here, as we can see, the conditions written here, a less than b, and so after doing modulo, it may be greater or it may be less than b, we don't know. And doing this again, the modulo, it may be greater, it may be less, we don't know. Okay, now so we have to find it for. Okay, now what happens if let's keep this condition, wait for a minute. Okay, let us say that m is less than a and less than b. Okay, now what if you do m mod a mod b, then what? Since m is smaller than a, then the value of this will be what? M itself. And after doing m itself, now m mod b left, and again it is less than b, so value will be what? M itself. And here if you the right hand side you check m mod v b mod a, so it is also equals to m. If you observe clearly, since b is greater than m, then again m, and m modulo a, and a is also greater than m, so it is m, and these two are equal. So what you have to do, you only have to check for this condition. Do you know? You only have to check the pairs under this condition, like this should be no, not this condition. You only have to check, that is pairs which are less than m, that is a and b should always be less than m, otherwise they are all valid pairs. Okay, otherwise they are all valid pairs. You just have to modulo and return the answer. Or the condition you have to check for is for this. Okay, so if m is like if m is what, let's say m let me check the constraint. M is 5 into 10 power 5, so it is 5 into 10 power 5, half of the n, so 5 into 10 power 5. So you have to check if n, suppose max to max it can give 10 power 6, so it is valid, but less than 10 power 5 you have to check n less than equal to m, you have to check for the condition. Okay, and n greater than, you don't have to check, all the pairs are valid. This is the condition, so you have to check for this. Okay, now what? I think this video is getting longer, so I will make the part 3 of this. So if you've not subscribed my channel, and if you like my explanation, I will be explaining this completely in the next video, and also providing you the code. So if you're not subscribed, then please subscribe, and if you like this video, then please give it a thumbs up, and happy coding. Thank you.